Right, here's another video from my No-frills playlist. Videos that are designed just to maximise points in exams by showing you common questions you'll get and how to answer them. So this is about velocity time graphs. There's a lot of questions come up, so I've done it as two parts. This is part one. Right, let's cut to the chase. What you need to know in an exam. Right, you need to know that the gradient or slope of a velocity time graph tells us the acceleration. You need to know how to interpret velocity time graphs, like they might give you a journey. You've got to say what's happening. And you've got to know how to calculate acceleration on a velocity time graph. So a little recap from the last video about acceleration. What is acceleration? Well, we said that acceleration was a change in velocity per second or per time, you know. So why? Why do I want you to know that? Well, what does the gradient of a velocity time graph tell us? Well, if you've got a velocity time graph, it means velocity goes up the side and time goes along the bottom. Because whatever you see first goes up the side, right? So velocity time graph. Now, if you've got a line that's going up like that, you basically, that object, the velocity is changing over time. Well, remember, the equation for acceleration is change in velocity in a certain amount of time. So basically the gradient of a velocity time graph tells us the acceleration. Okay, remember, to get the gradient of something you always do the y-axis divided by the x-axis. So in this case the y-axis is the velocity and it's changing, and the time is on the x-axis. So y over x would be change in velocity over time, which is the acceleration. Right, how do you interpret velocity time graphs then? Okay, so what might you get in an exam? Well, you might just get a straight line like that, and that basically means, because it's a constant line, constant slope, it means it's a constant acceleration. How do you get 3 marks though for being able to explain that? It's got a big acceleration, that's 1 mark because it's a steep line. Now you'll get a second mark for saying it's because there's been a big change in velocity, right? And you get your third mark for saying in a short amount of time, okay? So always talk about what's happening on the y-axis for a mark, and say what's happening on the x-axis for a mark, and then tell us what that means for your third mark, all right? So bearing that in mind, explain how object B is moving. Right, so the first thing to notice is that it's a flatter line, so that means it's a smaller acceleration, 1 mark for that. And then just tell us what's happening with the change of velocity. Well, the velocity's only changed by a little bit, hasn't it? And it's took ages this time, it's took a long amount of time. So a small change in velocity, 1 mark. A big time, 2 marks. That's why it's a small acceleration, 3 marks. Right, what happens if it goes flat like that? Well, it basically means it's a constant velocity. So remember, if there is a slope, it means there is an acceleration. So if there isn't a slope, it means there's no acceleration. Now, just be careful though, there's a common misconception. Because the line's gone flat, does that mean that the object has stopped moving? Well, the answer is no, right? What it means is the acceleration stopped, but just because the acceleration stopped doesn't mean the object stopped. Look, whatever the velocity is, it's not 0. For the velocity to be 0, it would have to be down here, okay? So the object has definitely not stopped. If it was a distance time graph, yes, when it goes flat, that means the object stopped. So don't get your velocity time graphs mixed up with your distance time graphs. That's what students always do. Right. What about this for a mark? If the line comes down like that, well, it means that it's slowing down. Don't say it's going backwards. That's what it would mean on a distance time graph. Right. Just say the velocity increased at first up to 10 meters a second. All that it means is that now the velocity is getting smaller and it's going back to 0. So a common question would be, when does the object stop moving? Well, the object would stop moving at 50 seconds, right? Because at 50 seconds, that's when the velocity got back down to 0, didn't it? All right. So just to recap that then, a steep line means it's a big acceleration. If it's not a steep line, that means it's a smaller acceleration. When it goes flat like that, that means there's 0 acceleration. In other words, constant speed or constant velocity. If the line gets down like that, it means it's got to 0, and so that means that it was slowing down. Look at this. Look at how steep this is going down compared to how steep that was. So this one is very steep. So basically, it's like a car, if you like. It's just tootling along, and all of a sudden, bang! Within a split second, the velocity went from whatever it was to 0. So that is a massive, massive deceleration. It's obviously crashed into a wall or something. And there's a little conclusion there. Just everything I've just said, so you can pause it if you want. There's definitely 3 marks worth of information there. The examiner loves you to say things like this, by the way. Statements, right? The steeper the slope on a velocity time graph, the greater the acceleration, right? Examiners love stuff like that. Because remember, science is all to do with relationships. Right. Einstein said that imagination is more important than knowledge. But we now know that you cannot have an imagination or be a problem solver without first gaining background knowledge. Because it's only when you bring all your background knowledge together that you are able to use your imagination to solve problems. So, using the background knowledge that I've just taught you, bring it all together and solve this next challenge. So what is happening here? Right, have a look. What do you think's going on? Now, there's a little hint. Look at the slope, right? It's a velocity time graph. Look at the slope. Is it getting steeper and steeper, or is it getting flatter and flatter? Well, you can see the curved line's getting steeper, which shows the object's acceleration is getting bigger. All right, because remember, the steeper the slope is, the bigger the acceleration is. All right. Now, use the way that I've just modelled that last question, right? Have a look at this. What's going on with this? Well, a little hint. Once again, look at the slope. Is it getting steeper or is it getting flatter? All right. So is this getting steeper or is it getting flatter? Well, the curved line's getting flatter, which shows the object's acceleration is getting smaller. All right. Remember, the flatter the line, the smaller the acceleration. And in actual fact, at this point here, it's completely flat, which means the acceleration is 0. In other words, constant velocity. All right, so we're putting that information together in order to answer questions like that. Right, so what do you think's happening at these different parts of the graph? All right, so common question. So A, that's a constant acceleration because it's a constant slope. B is 0 acceleration because it's like a 0 slope. This slope here is getting steeper and steeper, so that means the acceleration's increasing. This slope here is getting flatter and flatter, which means the acceleration is decreasing, getting smaller, approaching a constant velocity once I get to that bit. And then E, the velocity is getting smaller. All right, so it's decelerating. And then if it did say what's happening at that point, that's when the object's actually stopped because the velocity has got down to 0. Okay. Right. Here's 6 quick questions for you. Again, just to reinforce it, what's happening. So what's happening here? That's constant acceleration. What about that one? Again, constant acceleration because constant slope, but it's a bit faster this time because it's a bit steeper. What about that one? Well, it's a flatter, isn't it? So that's a smaller acceleration. This one, 0 slope, so 0 acceleration. This one, that's something getting slower, so decelerating. And this one, well, we said that if the slope's getting steeper and steeper, that means the acceleration's getting bigger and bigger. Right, so how do you calculate acceleration from the gradient of a velocity time graph? Now, this is how to get level 6s and above. So I've said the gradient of the velocity time graph tells us acceleration. So basically, we need to work out the gradient. Now, you'll not get a graph that's all over the place like that, right? What the examiners will do is they'll simplify the graph by making it straighter. Right, so how do you get the acceleration between points B and C? All right, so remember, acceleration, we need to know what was the time taken for a certain change to happen. All right, certain change in velocity. So you can see here the object's velocity is changed by 60. So it was at position B, the velocity was 10. At position C, the velocity is 70. So it's gone from 10 up to 70. So it's changed by 60. And it took 3 seconds for the change to happen. So to go from B to C was 3 seconds. So acceleration is change in velocity over time. So that's 60 over 3, which comes out as 20 meters a second squared. And that's how to get, 3 marks in an exam. Right, here's a few questions for you to try. Pause the video and have a look at them. Right, here's the answers. So what is the acceleration during the first 20 seconds? Right, well, there's your first 20 seconds. And so from there to there, the velocity went from 0 to 10. So the change in velocity was 10 and it took 20 seconds to do it. So 10 over 20 is half a meter a second squared. What's the velocity at 20 seconds? Right, we'll just literally go along to 20 seconds and just read it off from the graph, all right? So it's 10 meters a second. It's a velocity time graph. So to get the velocity, just look at the graph. Right. What's the acceleration during the last 40 seconds? Right. So there's your last 40 seconds, right? And basically, so from there to there, well, it's went from 40 down to nothing. So it's changed by 40 and it took 40 seconds to do it. So mind you, it's a negative 40, okay? Because the velocity's got smaller by 40. So minus 40 divided by the 40 seconds comes out as minus 1 meters a second. When was the object travelling the fastest? Right, well, just when did the graph get the highest, right? It's the highest there. So that's the highest velocity. And when was it travelling the fastest? Well, that's 60 seconds then. All right. Right, here's a few more. Pause the video and have a go. So if you weren't very good at the last lot, hopefully now that I've showed you how to do it, you'll be better at this bit. And that's the whole thing about practice, isn't it? You get good at stuff that you practice. Right, so Howie, get it done. Right, and here's the answers. So what was the acceleration in the first 20 seconds? So there's your first 20 seconds, right, from 0 to 20. So it's gone up to here, all right? So at 0 seconds, it was 0 meters a second. And at 20 seconds, it's 30. So it's changed by 30. And it's took 20 seconds for that change. So changed by 30, right? V minus U. So 30 take away 0. So that's just 30. Divide that by the 20 seconds, comes out as 1.5 meters a second. What was the acceleration between 20 and 40 seconds? Right, well, there's 20 seconds and there's 40 seconds. So basically from there to there. So it's gone from 30 up to 40. So it's changed by 10 and it took 20 seconds to do it. So from 20 to 40, that was the 20 seconds. So 10 divided by 20 and that comes out as a half. And when was the person travelling the fastest? Well, it's a velocity time graph. So travelling the fastest was 40 and it's travelling that speed between sort of 40 seconds and 80 seconds. Okay. So a little summary there, have a little sneaky peek at that. What we've basically said is a velocity time graph can be used to see when an object's speed is stationary, accelerating or travelling at a constant speed. The steeper the gradient of the line, the bigger the object's acceleration. And you can calculate the acceleration from the gradient of the line. Right, so you've just covered 20 marks worth of content. So velocity time graphs is a very popular question for the examiner to ask you. All right, so there's no guarantee that velocity time graphs will be on the exam, but if it is, we've got a good chance of getting some good marks out of it now. So well done. All the extra time and effort you're putting in to finding videos that'll help you is increasing your success. Alright? Work hard, be nice, and I'll see you in the next one. Bye for now.